Hi, my name is Casey Tilton, and in this video I will walk through a case study to build a model to predict political and non-political tweets. But first, we want to understand the data set that will actually be used to train this classification model. So the data set consists of 2,000 tweets that were manually labeled political or non-political. And the first thing that I did was I looked at the distribution or the number of labeled political and non-political tweets. So I found that there are a little over 500 political tweets and a little under 1,500 non-political tweets in this training data set. Next, I looked at the most popular words in these tweets that were labeled either political or non-political. And as you can see, rainbow, zombie, unicorn, COVID-19, etc. are very popular or commonly used in non-political tweets. Hashtag Black Lives Matter, hashtag BunkerBoy, CNN, etc. are most often used in the political tweets. And here are word clouds that demonstrate the same thing. But it's not enough to just look at the common words. We also want to look at the most common word pairs, or in other words, bigrams in the tweets. So here are the most common bigrams in non-political tweets. As you saw earlier, zombie was one of the most popular words, but zombie apocalypse is the most common bigram in the non-political section. And the most common bigrams in the political tweets are kind of what you'd expect. And here are the most common bigrams in the political tweets. So another way to explore this data set is by looking at the term frequency inverse document frequency scores. In other words, TF-IDF for short. I'm not going to go into the math behind this, but in layman's terms, these are the words that are most important to the political or non-political tweets, but also that are not common across both of the sets. So for example, rainbow, zombie, and unicorn, MTG, are most emblematic of non-political tweets and are highly unlikely to show up in the political tweets, whereas CNN, BunkerBoy, protests, George Floyd, Atlanta, etc. are very emblematic of political tweets and unlikely to be in a non-political tweet. But as you can see, like, these are very similar, obviously, to the bar plots I showed earlier, except that COVID-19 was one of the most popular non-political words, but is not in this non-political TF-IDF score plot, because although it is common, it also shows up sometimes in a political tweet. Another way to explore this data is through a sentiment analysis. And as I high level, like first look, here's what I did. I calculated the average sentiment of political tweets and non-political tweets based on two different specified lexicons. So first I used the Bing lexicon, which scores words as either positive or negative. So I rescored those as either 1 or -1, and then I summed up the scores of all the political tweets for words that matched the Bing lexicon, and then divided that by and took the average, divided it by the total number of words. And as you can see, the political tweets are slightly more negative than the non-political tweets. And I did the same thing for another lexicon called AFIN, and for AFIN, it scores words on a scale of -5 for most negative to 5 for most positive. And as you can see, the political tweets are much more negative than the non-political tweets. But I want to very briefly mention a huge caveat or limitation to this is I didn't do any statistical tests of significance for the differences of these means, but that's beyond the scope of this course. But just wanted to mention that it's something that you would want to do. So, of course, the next big step is to actually create a binary classification model that predicts whether tweets are political or non-political. And I used a method called elastic net regression, which is a combination of lasso and ridge regression. And based on a number of different trials, I ended up using both lasso and ridge regression equally, and that is what the alpha 0.5 means. So the results of the model. First, I ran the model on the training data set, which was an 80% slice of the labeled tweets. That had an accuracy of 90%. And then I ran the model on the test data set, which was a 20% slice of the labeled tweets. And the accuracy was 78.4%. So not as good as the 90%, but certainly better than a coin flip. This confusion matrix shows that the model is pretty good at predicting correct or accurately non-political tweets, but not as good at accurately predicting political tweets. So for example, it correctly predicted that 41 labeled political tweets were in fact, or correctly predicted that they were political, but incorrectly predicted 73 of them. So these are the most impactful terms according to the results of the model. So these coefficients are very negative, which means these terms are most likely to be in tweets labeled and predicted to be non-political, and these terms have the most positive coefficients, and that means they are most likely to be labeled and predicted to be political. And then, of course, the final step is to actually apply the model to new tweets. And we had a data set of 1,000 unlabeled tweets, and the results of the model are that there were about 875 predicted non-political tweets and 125 predicted political tweets. Thank you.